Okay, we're going to do a few quick examples of transformations of graphs. And let's start with this one. So we're told that we're going through the x-axis at -1 and 2, and that we're going through the y-axis at 4. So we've been given 3 points. That means that our transformation of the graph must include 3 points. Okay, so that's the original graph, y equals f of x. And first of all, we're going to have a go at finding minus f of x plus 2. Okay, so minus f of x plus 2, so I would do the -1 times bit first, since that's the order for operations, and then add on 2. So the first thing that I'm going to do is reflect the graph in the x-axis, which is the minus f of x transformation. Okay, so 4 will reflect down to -4. 1, 0. Well, 0 reflects to 0 and 0 reflects to 0 over here, so they'll stay there. And the curve will now look like that. I then need to move the thing up by 2 units, and that will look a bit like this. Okay, so -1, 0 now goes up to -1, 2. -0, -4 now goes up to 0, -2. And 2, 0 now goes up to 2, 2. Okay, now we're going to have a go at minus f of x plus 2, or x plus 2 is in the bracket this time. So that's -1 times f of x plus 2. So rules of BODMAS will tell me first of all to take care of the brackets, so that will be a first move of 2 units to the left, followed by a reflection across the x-axis. So let's have a go at that. And there's the original function again. So first of all, let's move 2 units to the left. Okay, so we'll get 3 points, so we need 3 new points. -1 will now go to -3. 2 will now come into 0. And 0, 4 will now come into -2, 4. Let's just make sure I get the shape of the thing correct. And that's that. I now need to reflect the thing across the x-axis. -3, 0 will stick at -3, 0, as will the origin. But -2, 4 will now reflect down to -2, -4. And the curve will look something like that. Okay, let's try another. Okay, so I've got an original function this time that looks a bit like this. Okay, so I'm cutting the x-axis at -1, 1 and 3, and the y-axis at 2. That's the original function, y equals f of x. The question is then asking me to find 2 minus f of x. Now, best rewriting that as minus f of x plus 2, which is the same but more intuitive to work out the answer. So I'm going to do the -1 times bit first, that's the reflection across the x-axis. And then plus 2 is telling me to move 2 up. So let's do the reflection first. Okay, so think about it, a reflection across the x-axis at 0, 0 and 0. Still give me 0, 0 and 0. But 2 will then reflect down to -2, and the curve will look something like this. Okay, and then I'm going to move the thing up 2 units. Okay, so if it moves up 2 units, this -2 will now go up to the x-axis. minus 1, 0 will now go up to minus 1, 2. 1, 0 will go up to 1, 2, and 3, 0 will go up to 3, 2, and the curve will look a bit like this. Okay, let's try another. And we've got an original function this time, which looks a bit like this. Okay, so it passes through the origin, 1, 1, 2, 0, and 3, 0. So that is y equals f of x, and I'm looking to draw the function which is minus f of x plus 2 in the bracket. So minus 1 times f of x plus 2, so I'll do the bracket first. Okay, so x plus 2 in the bracket is telling me to move 2 units to the left. And then I'm going to make the reflection across the x-axis. So 2 units to the left first of all. So I'll move from 0, 0 the origin to 0, minus 2. 2 will now come into 0 and 3 will come into 1. 1, 1 will come into minus 1, 1. And the thing will look a bit like this. Okay, I'm now going to reflect the thing across the x-axis. So these points will remain the same, but minus 1, 1 will reflect down to minus 1, minus 1. And the curve will now look like that. Okay, let's try a couple more examples from one curve. Okay, so this time we've got a curve which looks like the following. Okay, so it goes through a point minus 2, 2 here, passes through the y-axis at minus 2, and then cuts here at 1 on the x-axis. So that's y equals f of x. Okay, the first one we're going to have a go at drawing is going to be y equals f of 2x. Okay, so remember that that is a horizontal compression by a factor of 2. Okay, so horizontal compression by a factor of 2 minus 2, 2 will now compress into minus 1, 2. 0 minus 2, well if you compress 0 by a factor of 2 you still get 0, that stays the same. And 1, 0 will now compress into 1/2, 0. So it's basically going to be a kind of thinner looking curve now with my 3 new points. Okay, we're now going to look at y equals minus 2f of x. Okay, so that's going to be a reflection across the x-axis and a stretch by 2. So the reflection across the x-axis will look something like this. And this time going through minus 2, minus 2. Instead of minus 2 here, that'll be 2 up here. And still 1, 0. So that's the reflection. Now it's going to be the stretch by a factor of 2. So a vertical stretch will now stretch minus 2 down to minus 2, minus 4. 2 on the y-axis here will now stretch up to 4, and a stretch of 0 by a factor of 2 still gives me 0. So let's just vertically stretch the thing out then, and that'll look something like that.